Hello. 1 second. Apologies for the technical difficulties here. Let's see if we're here now. Great. It looks like we're back. Yes. Well, hello everybody. Apologies for the technical difficulties at the beginning when we were setting this whole thing up. Unfortunately, I was running a bunch of different live streams tonight, and somehow the system got out of sync in between. But nevertheless, let's go right ahead. So we're going to be talking tonight about some really interesting questions as part of this official collaboration with mathleague.org. Now, mathleague.org makes some really interesting problems, which I had the experience to play with last time, and I was really impressed by how innovative they were. So today, what we're working on is we're working on the questions that are from their middle school championship. What this means is that I'm probably going to have to sweat a bit because they're going to get harder. So let's go ahead and get started. Let me switch over to here. So here's where the questions are. And the way that this is going to be is that, in case you haven't seen one of these live streams before, I'm going to attempt to solve these problems right now on the spot. I noticed some people saying that the video seems a little bit fuzzy. That might be because I had to restart the system in between. If it looks fuzzy for you, I think if you just try refreshing your screen, it should end up being clear. So hopefully that will solve the problem. Okay. Great. So let's go ahead and get started. Today, we're going to work on some questions which our team has picked. And these particular questions are all problems for which I haven't gotten the chance to think about them yet, on purpose, so that you can see how somebody would go about thinking about these for the first time. Okay. I have to zoom in a little bit more because it is far away from me. Here we go. State sprint number 4. How many 2-digit numbers are divisible by 5 and have a tens digit of 3 or 7? I think I can do this. So if the tens digit is 3 or 7, then it's either going to be 3 or 7, and that's the tens digit. To be divisible by 5, it has to end with a 0 or a 5. So it looks to me like I have 2 choices times 2 choices, so that means I have 2 times 2 equals to 4, right? So I've got 2 choices for this one. Oops. 2 choices for that number, 2 choices for that number, I get 4. Let's try that. And we all know that the questions are going to get crazy hard as we go. Yes, okay, while I can get the question, I'm going to celebrate, and let's keep going. Question number 6, state sprint number 6. And this says 3 fair 6-sided dice, which are colored red, blue, and green, are rolled. What is the probability that the sum of the results of the red and blue dice is less than half of the result of the green die? Express your answer as a common fraction. Okay, well, let's see. Oh, somebody just said that they refreshed and I look a little bit out of focus. I'll say, let me run around to the camera to make sure that's not a problem, but I'm going to run around and just double check that. Maybe that's the case. Hang on. Strangely, the camera hasn't moved, so I think there might just be something a little bit fishy with the way that this is broadcasting. But we'll continue with this. So I generally don't mess with the camera because of the various focus issues. I'll try not to move as fast. Okay, so now what we're looking at here is we have these three fair 6-sided dice, and so if I've got a red, a blue, and a green, and the way I would take this apart is I would look at what the different possible answers are for the green, right? If I want to be less than half of the result of the green die, well, what are my different choices? So if the green die was a 1, how do you get less than half of 1 as the sum of 2 numbers? You just can't, because like the sum of the other 2 dice, which is red and blue, the smallest it could be is 2. Oh, if the smallest it can be is 2, hey, red and blue is like purple, right? So this is like red plus blue. So I see that over here it's like, no, that's no way you could do this. But if I could make the sum of the red and the blue dice to be less than or equal to 2, which is the absolute bottom it could be, well, then that would correspond to green die being 5, okay? The way I got that, now I'm actually going to start here and go there, but I'm saying that if I had anything up higher, like 4, to be less than half of the green die, I have no choice. I can't get red plus blue to be less than 2. At 5 is the first place that I can get less than half, okay? And then the next one would be 6. In order to be, if it's 6, the red and the blue has to be less than half of it. Well, it has to be less than 3. Oh, that's neat. That's less than or equal to 2 also. Oh, this is very convenient. Because if I look at it, it's like even if the green die was 6, less than half of 6 is less than 3, and it's an integer, red plus blue, so I only have these options. So now it's actually quite nice, because in order to get red and blue to be less than or equal to 2, that means both are 1. So really, I just have 2 different possibilities. Green is 5, red and blue are both 1, or green is 6 and red and blue are both 1. So I've got 2 legitimate possibilities. I have a better way. I was gonna tell you I've got something and I'll divide. Okay, I'll tell you what I was gonna do. I was gonna take 2 divided by 6 cubed, because each of those dice has 6 options. But then another way to see this is that the green die could be 2 out of 6 options. That's 1/3. That's being a 5 or a 6. And then the red is going to be 1 out of 6, and the blue is going to be 1 out of 6, because both the red and the blue are forced to be just the number 1. This is another way. And so now I need to know what's the sum of this. So this is 1 over 3 times 6 times 6. 3 times 36. Oh, that's 108, I think. Yes, and I double checked it in my head because I know that 6 cubed is 216, and half of 216 is 108, and 3 times 36, that's also 108. So it looks like it's 1 over 108. Reading the question again, seems legit. We're going to try this, and we're going to see if that's the answer. It is. Let's keep going. Shuba the duck is at the edge of a circular lake whose surface takes up 625 pi square meters. To swim to the opposite side of the lake, Shuba may swim in a straight line along a diameter. She may alternatively swim 14 meters in a straight line before reaching the edge of the lake, and then swim D, or is it A? That's an A meters in a straight line before reaching the same destination. What's the value of A? Okay, so if I see this 625 pi, I'm like, 625, I like that number. 625 is 25 squared. Oh, hey, there's a pi r squared formula, right? So if the surface of the lake takes up pi r squared, what's r? Well, that means that r, the radius, let's draw a diameter because there's a diameter we're playing with, but the radius is 25. So here's another 25. Okay. Next, it says that Shuba has another option, 14 meters in the straight line before getting somewhere. Maybe that's 14. And then this mysterious A. So we want to know what A is. Oh, okay. So this is an interesting fact from geometry. In geometry, if you have a semicircle and you have a point on the semicircle, then the angle, look at what that angle is. What do you think that angle measure is? What does it look like? Well, there's a way to prove this too, but that's beyond the scope of this short live stream. But that's a right angle. And this is also a tip for like draw pictures as cleanly as you can, because you might notice some interesting coincidences. Okay, so in that case, I'm going to be talking about a right triangle, and it has 25, 25, and 14. Should I just go and use the Pythagorean theorem with 50 and 14? Well, we should first reduce that down a bit, because 50 and 14, those are both even. So I can say that this particular thing is exactly double of another thing. If I just use a normal 25, let's halve the 14. That's a 7. Now this is really nice. So there's a 7 and 25. There's 25 for the hypotenuse, 7 on that side. It turns out that this actually is a nice number. If you want to know what that number is, I can show. 625, let's do Pythagorean theorem. We'd have to do square root of 625 minus 49. Where can I fit that? Yeah, let's do it here. 625 minus 49. 15 minus 9 is 6. Okay, so 11 minus 4 is 7. 576. So that turns out to be a perfect square. You can actually even guess what that would be. That's going to be something squared that is close to 25 and it ends in a 6. What squared ends in 6? 4 squared ends in 16. That's a 16, right? So it's actually 24. And another fun fact, if you have seen some of my live streams, the difference between two consecutive perfect squares, like 25 squared and 24 squared, is exactly 25 plus 24. We've talked about that a bunch of times. You know what's 25 plus 24? 49. That's why this works. I mean, that's why this is consistent. So that means that the A is double of it. So A is supposed to be 2 times 24, so A is 48. Okay, let's see. It is. Let's keep going. Next, a geometric sequence has 3 consecutive terms of y minus x plus 2, y plus x. Okay, sorry. A geometric sequence has 3 consecutive terms of y minus x plus 2, y, and y plus x minus 2. What is the common ratio of the sequence? In a geometric sequence, the ratio between 2 consecutive terms is equal and non-zero. For example, 2, 6, 18, 54, 162 is a geometric sequence with common ratio 3. So when I look at this, there's a neat thing about geometric sequences, which is that I could write, well, let's write it as ratios first, and then I'll show you the neat thing that happens. If they have the same ratio, that means that y divided by y minus x plus 2 is supposed to be equal to y plus x minus 2 divided by y. What I just did is I looked at the ratio. The ratio of this divided by that is supposed to be equal to ratio of this divided by that. Okay? Now if you cross multiply here, you'll get y squared is equal to y minus x plus 2, y plus x minus 2. And this is what I wanted to say is a neat thing. Whenever you have a geometric sequence, it actually turns out that if you have 3 consecutive terms, the middle one squared is the product of those 2. And so that would be actually what I probably would have written down first. But I wanted to show you how you get it. You can get it from this ratios and saying the ratios are the same. Okay. Well, in that case, I guess I should try to expand this. The good thing is that's a difference of squares. This is y minus of parentheses x minus 2. And this is y plus parentheses of x minus 2. That's convenient. So I have a difference of squares. Y squared is equal to, now it's the difference y squared minus x minus 2 squared. Oh, this is so neat. So what we're seeing now is that I have a y squared on both sides. So let's subtract that off. How could I possibly have 0 equals x minus 2 whole things squared? I knew it. I mean, these problems are always really creative. Because I was like, how do you solve this problem? There's y's and x's inside it. But how do you get this? So if I want to have something squared equals to 0, you only have one choice. The thing has to be 0 in the first place. Actually, that thing squared is negative 0, which is also known as 0. Okay? But so now I found out that x minus 2, that's 0. And so that tells me that x is equal to 2. Really? Oh, wow. What a clever problem. Okay, so I was like, how can I use this? I still have a y. What am I going to do? Well, if x equals 2, what's going on? I have y. Oh, wow. So that's like they're all the same. So if they're all the same, that means that the common ratio is 1. They're just like all the same number. Oh, that's really neat. So I just found out that y. And so the ratio is equal to 1. Let's see if that's right. Y. Okay, excellent. I see that my moderation team just sent me a message. Do I have to do this? Oh. Strange. So I'm just going to comment to my moderation team, there should not be a problem with what you're discussing, because I have a bunch of people who are in that way. Okay, right, let's continue on. All right, so now that was really neat, by the way. I saw like y's and x's, and I was like, how in the world are you going to solve this problem? But it was really clever. The problem writers were really clever. More stuff. Problem number 11. Amelia adds together a 3-digit number and a 2-digit number. However, she forgets to carry the 1 every time it is needed and ends up with an incorrect answer of 171. What is the sum of all possible correct answers to the addition problem? Whoa. Okay, this is nifty. I don't know how to do this. Okay. So I have a 3-digit number adding to a 2-digit number. Okay. And somehow the answer is wrong. It's 171. And interestingly, it's saying that that's an incorrect answer, okay? And we're supposed to add up all possible correct answers. So now we need to see, where could the carrying be forgotten? Oh, this is neat. Okay, so could she have forgotten to carry there? Well, no. If there was a carry there, yes, possibly, because it's the wrong answer. It's the wrong answer. Oh, wow. So in that case, where are the possible forgot to carry places? Well, okay, I was going to say, could she have forgotten to carry at the beginning? Well, there's no carrying at the beginning. So there's like 2 places here you could have forgotten to carry, right? You could have forgotten to carry here, and you could have forgotten to carry there. I wonder if this is possible to have, like, forgetting on every possible combination of those. Every possible combination, meaning for each of those it's either, yeah, I remember, or, oh, I forgot. Sorry, that's not what I'm supposed to say. She forgot every time. The question is whether or not she was supposed to, right? So what I'm going to write here is like, either you were supposed to carry or you weren't supposed to carry. And now the question is like, you see, there's 3 possibilities. Either you were supposed to carry both times, or you were supposed to carry one of the times, or the other time. But you don't have to worry about the option where you weren't supposed to carry at all, because it says that she forgot to carry and got the wrong answer, so she better have been supposed to carry. Okay, so let's just go and try to think this through. So if it turns out that she forgot to carry, let's write a table, okay? So here's the question. Did she forgot? Well, no, let's write supposed to carry. Supposed to carry. Supposed to carry. Well, I've got the 2 possibilities, right? And the I've got these 2 things, on the hundreds and on the tens. And so I'll write down the possibilities. Either it's like, yes, I was supposed to carry, and yes, I was supposed to carry. Or yes, I was supposed to carry, no, I wasn't supposed to carry. Or no, I wasn't supposed to carry, yes, I was supposed to carry. Okay, so if you were supposed to carry on both, then it looks like the answer you should have gotten is 281. A little bit of me wants to double check. Is it possible to make some numbers where you're supposed to have carried on both and the answer is 281? Well, if I wanted to just make that happen, how would I make that happen? I just want to see. So if I wanted to make 281 where I forgot to carry, but I'm supposed to carry, I guess I'm just like making stuff, right? It's like I could do like 0 plus 1 as well. Ooh, I'm supposed to carry on both. So it better not add up to 1, it better add up to 11. So 5 and 6, that's how I was supposed to carry, right? And then I'm supposed to get 2 numbers that add to 7, but they're supposed to carry, so they're supposed to add to 17. So that's like 9 and 8. That was supposed to be a 9. Do you see how I thought through that? I was like, if I want to make an example of something adding to 281, I just need to know 2 numbers that add together and don't give me 1, but give me like 11. It's like 1 plus a 10. Okay, I did that. Then I need to find 2 numbers that add together not to 7, but to 17. And I just did that here, okay? And now I have been supposed to carry on both of them. So 281 is legitimate. Okay, well in that case, now that I've seen that, everything's going to be similar. Because the next one is going to be, let's see, the next one should be 271. Because that would be something where I'm supposed to carry over here, but not over there. And is it possible? Yes, this one's going to be possible. I already see how this is working. Because I just need 2 things that actually, wait, no. Let me fix this. 271 is what I want, but I was supposed to carry on the front. So that would be a 9 plus 8, making a 17. And to make a 1, I do a 0 and a 1. You see how I did that? I was like, I'm not supposed to carry on this guy, so I should add up to the 1 now. And I am supposed to carry here, so I need to make this add up to 17. So 9 plus 8 is 17. Okay. And then over here for New York, or no yes, I need to make this, I guess, the carry will be in the middle, so it'll be 181. And that's possible. I see how this is working. So for the 181, that's what I wrote the first time. Like 5 plus 6 is 11. And then I maybe do 3 and 4 here, where it adds up to 7, but you were supposed to carry, and that makes the 181. All right. Okay, so in that case, I just need to add these 3 together, because the point is that she did forget to carry at least one place, because 171 is wrong, and so let's add these 3 together. Hopefully we remember to carry. 1 plus 1 plus 1 is 3. Oh no, what's this? So 8, 7, and 8. Here's how I'll do it. That's like 3 8s. 3 times 8 is 24. But subtract 1, so it's 23. Okay, 2, 2, 2, that's 6 plus 1, 7. So I'm coming out to 7, 3, 3. Let's see if this is right. Yes, we're good. Okay, let's keep on going. Drink some water as we go. What is the area of an equiangular octagon with 2 sides of length 2 root 2 that are parallel, 2 sides of length 4 root 2 that are parallel, and 4 sides of length 5, none of which are next to each other? Whoa. Okay, first I need to understand what this looks like. Okay, so it's got 4 sides of length 5, none of which are next to each other. That's like it's like a stop sign, right? So in that case, it's like a really smooshed up stop sign. That's what I'm going to try to draw. I think I understand what this looks like. I think it's going to have some long thing and some short thing. And this might not be to scale, but it's going to look something like this. These are 5s. These are 2 root 2s. And these are 4 root 2s. And it's an equiangular octagon. That means all of the angles are 135 degrees on the inside. Okay, so in that case, I just need to find the area. How to do something like this? Well, I guess it would be nice to kind of know some of the lengths that are involved. Yeah, okay, let's go and make some lengths. So if I have a 5, if I want to know what each of these little bits says, it's a little bit annoying because 5 is an odd number. But if I have this type of a right triangle, the ratio that they go by is 1, 1, root 2. So if I want to know each of those, I need to do what is 5 divided by root 2, right? And a fun fact is if I want to do 5 divided by root 2, it's no fun to have a root in the bottom. So we can take 5 divided by root 2 and multiply by root 2 over root 2. That's just 1. You can always multiply by 1. And that's 5 root 2 over 2. So that's actually the length of each of those little bits. Okay. Now, the reason I did that is, I guess, I should actually probably just have done 5 over root 2. That would be easier. But the way I'm going to look at this is I've got these little tiny pieces. All right? So I've got these 4 little pieces. Each of them is the same. And then I also have some other pieces that I need to put together. So let's just go and break this whole thing up. I'm thinking. I'm a pretty lazy person. I have a better idea. Too hard, too hard. This was too hard. Let's not do it that way. I am going to change my strategy to be even more lazy. Hey, what if I just take away the outside? So now what I'm going to do is I'm just going to find out what is the big rectangle and subtract the 4 little triangles. Okay? So let's try that. So if I want to have the whole big thing, I now know this is 5 root 2 over 2. That's still the length of this little piece, but there's 2 of them. So the 2 of them together are giving me a normal 5 root 2. So what that's telling me is that the entire length, this entire length is 4 root 2 plus 5 root 2, which is 9 root 2. That's convenient. I can do the same thing here. This is 2 root 2 plus 5 root 2, which is 7 root 2. Aha! So now I know the area of the big rectangle. So the big rectangle has area is equal to 7 root 2 times 9 root 2, which is 7 times 9 times 2. That's 63 times 2, which is 126. Now let's just subtract away these 4 little pieces. Well, what are those 4 little pieces? I have this, this is 5 root 2 over 2 is each one of them. I'm lazy. There's a better way. There's a better way. Look what happens. Hey, I've got these quarters, right? What if I take these 4 quarters and I put them all together? You know what you get? So I'm talking about the missing pieces, like those pieces there. All right? So I have all these missing pieces. That's like a quarter. That's a quarter. You grab that one and you slide it over there and you put it there. You see this one here? We slide this up and we put it there. And you take this one here and you slide it all the way over there. What did you get? You got a square. Awesome. So it's a square. So what I actually get if I put those 4 pieces together is a miraculous thing. You see why I said I'm lazy? I like to find ways to do problems where I have as little calculation as possible. Hey, does anyone know what area I should subtract? This is pretty good. So it's just a 5 by 5 square, right? So the area that I subtract has to just be 25. Nice. So then you subtract 25, and you get, I can even do that in my head. 126 minus 25 is 101. All right, reading the question again, just making sure I understand what it said. Yeah, looks right. So let's see if the answer is 101. It is. Okay, that was nice. I saw somebody said, how do I not realize those things? Well, honestly, you see, if you can see how I was approaching these problems, it's because I just don't like calculating. So whenever I see that, oh no, I'm going to have to add a whole bunch of stuff together, there's a lot of stuff going in my head saying, you don't want to do that. Is there anything else you could possibly do to make it better? Okay? The real reason is because actually, even though I say lazy, it's not right. That's not really what I'm afraid of. What I'm afraid of is I make tons of arithmetic mistakes. And so if you make yourself do too much arithmetic, you're actually just inviting possibly making mistakes. Okay. Whoa, what's this? Question number 13. If x is a real number such that x cubed plus x squared plus 16 equals 16 parentheses x squared plus x plus 1, then what is the sum of all possible values of x cubed plus x plus 16? Whoa. Okay. Let's see. Is there anything nice about this? We'll find out soon. So I have an equation. Let me start by looking at the equation and seeing if there's anything to simplify in it. X cubed plus x squared plus 16 is equal to, I'm rewriting it in one row, so hopefully I can see some patterns. Also, I'm expanding it out. 16x squared plus 16x plus 16. We are hoping that something good will happen here. Okay, so I see a 16 on both sides. So let's just try to divide that out on both. Next, I guess I could try to put everything together. Now I find out that x cubed, subtract stuff so that everything's on the same side. X cubed minus 15x squared minus 16x is equal to 0. Ooh, now that's nice. The reason that's nice is because I can factor out one of these x's. I was scared because I saw an x cubed. I actually don't know the cubic formula. I know the quadratic formula, but I don't know the cubic formula, even though there is one. But now let's see. If I take this out, then I could factor it as x times x squared minus 15x minus 16 equals to 0. Okay. Now this one actually factors also. X squared minus 15x minus 16. Maybe some of you can see that already, but I'll just do it slowly. If I had an x squared and I have a minus 15x and I have a minus 16, I guess the way I often think of this is you got the x, you got the x. How are you going to do something with 16, like two things that multiply to 16, which gives you like a 15? To me, that's like 16 and 1, if you subtract them the right way. So one of these is going to be 16, one of them is going to be 1. And I want it to make me a negative 15, so let's put a minus 16 there. Now I suddenly get a cross term of x and minus 16x. That's minus 15x. Okay, so now we're good. So now we find out that we can continue factoring this. X times x minus 16 times x plus 1 is equal to 0. Or you know what that means? Whenever you have a bunch of numbers multiplying together and they're 0, that means that at least one of them is 0. So x equals to 0, or x is equal to 16, or x is equal to minus 1 are the solutions. And strictly speaking, you should actually go and plug them in and double check. I actually know it's going to be equal because in fact over here I didn't do anything other than rearrange and factor. So actually every one of these statements I've written here is equivalent to the previous one. I didn't square both sides, I didn't square root both sides. This equation is exactly the same as that equation, is exactly the same as that, exactly the same as that, where all I've done is add and subtract stuff from both sides. That's the reason I actually don't have any extraneous solutions. But now if I look at this, I now need to know what? I have to go and sum all of those? Oh no. Is there a better way to do this? So let's see. Is there an easier way? I'm trying to think because you know what I'm about to say. I'm gonna say I'm kind of lazy. How do I do that? I might have to add some stuff together. X squared plus x plus 16. Oh, sorry, x cubed plus, okay, I have some easier way to save it, okay? Here's what I'm going to do, all right? I'm too lazy to actually add up these possible values. But the problem writers told me that each of those is equal to those. Maybe that's easier, right? So instead it's easier to just sum the values of 16 times x squared plus x plus 1. I like that better. Okay, and in order to do that, let me just sum the values of x squared plus x plus 1, and then whack it by a 16 at the end. Multiply it by a 16 at the end. Okay, so that's equal to 16 times sum of values of x squared plus x plus 1 for x equals to 0, -1, and 16. Okay, so that's all I have to do. This is hopefully easier. Is it easier? Let's try. So I need some more space, so I'm going to write it on the next screen. So I need to know what is the sum of the values of x squared plus x plus 1 for x equals to 0. That's supposed to look like a 0. X is equal to -1, and x is equal to 16. Right? That's what I need. And at the end, I'm going to multiply it by 16. Okay. So let's go ahead and do this. So this is not that bad. The first one, I can see that if x equals 0, the answer is 1. I love plugging 0 into polynomials because like all the x stuff disappears, right? Like plug in 0, 0 squared plus 0 plus 1, it's just 1. How about the -1? The -1 is going to give me -1 whole thing squared is a 1, and then a minus a 1, and then plus a 1. So that's going to give me 1. Whoa, that's interesting. Now I'm looking at this. Ooh, tricky question. Tricky question. What's the sum of all possible values? Wait a second, I just repeated a value. If I repeated a value, I shouldn't sum both of them. Right? It's not the sum of all values, it's the sum of, well, I mean, it is the sum of all values, but it's just like, I can plug in two different numbers and get the same value. Ooh, okay, that's interesting. So that's actually not new. I'm just going to mark this off as a don't include that one. Don't include that one because I already got it. I already have a 1. Okay, the last one. The 16, that's 16 squared is 256 plus another 16 plus a 1. What's that? I guess I have to add it. Okay, 256 plus 17. I just somehow don't like writing stacks of 3 things adding together. So if I can just add 16 and 1 easily, I'll do that. 6 and 7 is 13. Okay, I think it is. Yeah, okay, 5 plus 2 is 7. 273. So that means that my sum of all the possible values here is 274. But remember, remember, we have to whack it by the 16. Or, I mean, multiply it by the 16. Ugh. I guess I have to. Okay, here goes. 274 multiplied by 16. Yeah? Yeah. Okay. Here goes. Oh, wait. Yeah, that's right, that's right. Okay, because I saw some people putting in the chat 273, but we have to add together all the possible values. That's why I added that one. So now I've got 274. 6 times 4 is 24. 6 times 7 is 42, plus 2 is 44. 6 times 2 is 12, plus 4 is 16. Do I believe that? Let me show you how I quickly check. It's because if I multiply 274 by 6, 6 is a multiple of 3. Therefore, I expect that this to be a multiple of 3. And I can see that because 6 is a multiple of 3. 1, 4, and 4 add up to 9. So the sum of the digits is a multiple of 3. I haven't made an obvious mistake yet. And now let's continue. Here we go. And then we add 4, 8. 6 and 7 is 13. Wow, 4384. I wonder if that's right. What a big number. 4384. Let's see. The moment of truth. It's right. Okay, I was scared. Okay. By the way, you can see my laziness sort of paid off. If you go back here, because does anyone really want to plug x equals 16 into x cubed plus x squared plus 16? No, that could be bad. What is 16 cubed anyway? What is 16 cubed anyway? So 16 cubed happens to be, if I wanted to do it in my head, 16 is 2 to the 4th, so that would be 2 to the 12th. Okay, that would be 4096. But that's like some crazy number and no fun to do all of this. So I think we're good. Okay, great. How are we doing on the time? Just checking. We still have time. Let's keep going. Okay. Oh, the questions get longer. Question number 14. In Japan, the 2020 Cherry Blossom Festival takes place on 5 separate days. March 19th, March 20th, March 21st, March 25th, and April 7th in Tokyo, Fukuoka, Nagoya, Osaka, and Sendai, respectively. Sakura wants to visit at least 2 of the festival events, but she does not want to go 4 calendar days in a row without attending a festival event during the 19th to the 25th inclusive. Additionally, she does not want to go to 3 consecutive festival days during that time period for fear of exhaustion. She also does not want to visit Sendai if she has already visited the Tokyo festival. In how many ways can Sakura celebrate the festivities? Oh my gosh. Oh boy. So this is like so much to read and understand what's going on. All right. So one thing at a time. So I see that there are these 5 different cities. Okay. So let's start to highlight things. Also because I don't know Japanese, so it takes me longer to go and figure out, which is which. All right. So I've got this Sendai. I also have the Tokyo festival. I'm just trying to mark, information. So she doesn't want to. Okay, so it's like, so you'll get exactly one of those 2. Oh, that's neat. That's neat. So what this is saying is that, sorry, you have at most one of those 2. So let's make them both actually green. That's going to be interesting. What I'm going to say is that as I'm reading, oops, wrong pen. As I'm reading this, I'm seeing that there's green and there's green. And what I've just found out is that you can't take both greens. I'm just trying to interpret the information, okay? So I've just dealt with this last piece of information. Is there other stuff that I can deal with? So also I see that she does not want to go to 3 consecutive festival days during that time period. Wait, there's this time period thing. So let me go here. Sakura wants to visit at least 2 of the festival events, but she does not want to go to 4 calendar days, does not want to go 4 calendar days in a row without attending a festival event during the 19th to the 25th. Okay, so these are like some important days, and she wants to make sure that she does not go 4 days in a row without attending. How could you go 4 days in a row without attending? I'm just looking at this and I'm being like, well, if you have the 20th and 25th, there's 21st, 2nd, 3rd, 4th in between. Okay. So what I'm seeing here is that you don't want to go 4 days in a row without attending. I'm just trying to parse that, right? I'm like, if you had the 25th, you actually still have to take the 21st. That's how I'm sort of seeing this. You can see I'm thinking. I'm like, well, another way I can think of this is, oh, look at that. 22nd, 23rd, 24th, and 25th. That's 4 days in a row. I'm just brainstorming as I'm solving this. So the 22nd, 23rd, 24th, and 25th, that's 4 days in a row. You know what that means? Because Sakura doesn't want to go 4 days in a row without attending a festival event during that period, 19th to 25th, inclusive. What does that mean? That means that Sakura has to attend the 25th, right? Because inside that particular window, inside that particular period, if Sakura doesn't attend the 25th, then that would be 4 days in a row, okay? So what I've just found out is that I definitely need Sakura to attend March 25th. Actually, March 25th is Osaka. Okay, so that's a definite. That's nice. I like definite information when I'm trying to understand what's going on in the problem. So definitely attend the 25th. No choice at all on that one. Okay, so what have I done? I still need to visit, Sakura needs to still visit at least 2 of the events. We already got 1 of them, for sure. But she does not want to go 4 calendar days. Okay, we dealt with that already. Okay, additionally, she does not want to go to 3 consecutive festival days during that time period. That's the time period 19 to 25. So she does not want to go to 3. Oh, wait, there's more information. Wait, so I definitely have to take this one. And now I also know that I can't go 4. She can't go 4 days without attending an event. Therefore, I don't know anything about the 21st, do I? I'm trying to say I think that she has to attend at least one of these 3. The way I'm coming to that is that the reason that I know that she has to attend at least one of these 3 is because, you know, if you have the 25th, you do need something from here. Because, for example, if there was nothing from here, then from the 19th and 25th, you're stuck. That's like, I mean, it's just too long. So what I'm finding out is that Sakura has to attend one of these 3 as well. One of these 3. At least one of these 3. But we don't know which one. And whichever one we attend is going to already satisfy the issue about the 4 calendar days. This is a pretty hard problem. So the next thing I know here is that over here, at least 1. Maybe let's use a different color. So the next thing I know is over here, at least 1 of these. Okay? So I know there's at least 1 of those. And also she does not want to attend 3 consecutive festival days. Oh my goodness. So I'm going to guess that the 3 consecutive festival days, I'm guessing that because it says, I'm trying to think, does 3 consecutive festival days mean 20, 21, and 25 can be considered 3 consecutive festival days? I'm going to interpret it that way at first, because sometimes if I tell you something like, hey, did you do something on 3 consecutive weekends? I don't mean it's impossible because weekends aren't consecutive days, right? So I'm going to guess that 3 consecutive festival days just means we don't want 3 of these. So we can't, for example, have 20, 21, and 25. Okay? I'm still continuing to puzzle through what we have here. So as I'm looking at this, I'm like, for sure there's the 25th. Okay? And I need to have at least 1 other day somehow picked in this whole thing. And there's this last part about Sendai if already visited the Tokyo Festival. Okay, and I need at least 1 of these other ones. Well, there's one way to do this, which is to say, let's go and just like list out the possibilities, because this looks very complicated, okay? So let's go and start making some tables. Here we go. I want to see the problem statement here. So what do I have? I have the 19th, I have the 20th, I have the 21st, I have the 25th, and I have the 7th, okay? And let's start making some possibilities. So we are saying the 25th is a for sure. That was a for sure, okay? And now I have to say, what are the ways that I could get at least one of these? And I'm actually just going to do some crazy listing. So I could do like no, no, yes. Oh, interesting. But it's 3 consecutive festival days during that time period, okay? That's fine. People are saying that, yes, I am getting confused. And that's because this is a complicated logic problem, all right? So I have no, no, yes, yes. That's one possibility. I'm actually looking at this where I'm saying the yes here is fixed. There's no flexibility on that one. And I'm trying all different inputs here of like, I'll have 7 possibilities. I might run out of space. But so with the no, no, yes, well, if I have this, then I still have to think about what happens on the 7th. And I need to know that okay, I'm just reading this, right? Wants to visit at least 2. That's already done here. Does not want to go to 4 calendar days in a row without attending. We already dealt with that possibility by forcing at least 1 from there. No 3 consecutive days during that time period, but that's this particular time period. That's satisfied. And now there's this last thing of does not want to go to Sendai if she has already visited Tokyo. Tokyo is the first one, but she didn't visit Tokyo. So there's 2 choices now. This one's either a yes or a no. So this particular option gives me 2 ways. Okay, next one. No, yes, no. And then this is a yes. The pattern I'm using, by the way, is sort of a binary one. I'm going no, no is like 0, yes is like 1. This is the number 0, 0, 1. This is the number 0, 1, 0. In base 2, those are the numbers 1 and 2. Well, if I look at this, here I also have 2 choices. It's either going to be yes or no. So there's 2 choices. Okay, here we go. Let's keep going. I can do no, yes, yes. This is bad, bad, bad. I can't do this because there's 3 yeses in a row. Right, so I rule that one out. That's not okay, and I'm cleaning that out only because I don't have enough space on this drawing place. The next one would have been yes, no, no. Continuing the idea that this is sort of like writing numbers in binary. Well, now that's interesting because if I have a yes on Tokyo, does not want to visit Sendai, so that better be a no. Okay. So we got this. Is this good? Well, now we need to look at this carefully, right? As we look at this carefully, did we really use everything? Well, everything we said that was like what was necessary, right? But as I'm looking at this, there's still one piece we need to be a little bit careful of. This is like 4 calendar days in a row without attending a festival event. These seem like really far apart. Oh no, actually if I look at that, are those too far apart too? Oh no, those are bad. Actually, as I'm looking at this, I'm like, oh no, this is also bad. The reason this is also bad is because 20 and 25, the gap between them is 21, 22, 23, 24. So that's also a no-no. This is actually not okay. And I will say, thank you for the people in the comments. I occasionally look at people in the comments and somebody made a comment of like, don't forget the 4 consecutive days. And well, I would have gotten that one wrong, by the way, because over here, I would have missed that one. But let's go over here. This is like even farther apart, so that's not okay. Okay, so as we continue, yes, no, yes, yes. That one seems okay. Because I don't have any 4 consecutive days. Okay, this looks good. So there's 1 here. The next one is yes, yes, no, yes. We're learning something. This is bad for the same reason that one was bad, right? Because this one has a 4-day gap. So this is out. And finally, yes, yes, yes. This is like super exhausted because there's too many of these. Hang on. Why did I miss one? Shouldn't there be a no? Oh, I already erased that. That's right. So this is just too many yeses. So that's out. So it looks like I have a 2 and a 1. It looks like the answer is 3. So let's see. Before we go and reveal the answer, let's go and like read this again and make sure we understand what in the world we just did and see if this is right. So what we have here is we've got these 5 separate days, okay, 19th, 20, 21, 25, and April 7th, okay, got the 5 cities in Japan. Need to visit at least 2 of them. Did we visit at least 2 of them? Yes, we did. Okay. Let's see. But she does not want to go 4 calendar days in a row without attending a festival event from 19th to 25th. And that's why we ruled out a bunch of these extra ones that were here. because, for example, 20 to 25 is too far apart. Okay, great. And additionally, she does not want to go to 3 consecutive festival days in this thing. Okay, we dealt with that too. And yeah, okay, I think this is right. Let's see. Oh, somebody told me that the answer is wrong. Well, I'll still put the answer as 3. I do see somebody said that the first one is wrong because there's 3 consecutive festival days. But the thing is that when I was reading this, I saw like, what is it? Does not want to go 4. Additionally, she does not want to go to 3 consecutive festival days during that time period. So my interpretation was that the time period was the 19th to the 25th inclusive. I might be wrong on that. Maybe I'm misinterpreting the question. But the way I originally interpreted the question was the during that time period referred to the time period 19th to 25th inclusive. That might be wrong, actually. So we'll find out. So that means the answer is, I think the answer is either 3 or 2. Let's find out. I was going to put 3. Actually, I was going to put a wrong answer that's even bigger. So I put 3. It looks like the answer is 3. So there's 2 possibilities here. Either I interpreted it correctly, or I made another mistake and 2 wrongs somehow made a right. But if people here have observed that I've miscounted something, please let me know. I'm just going to say my general way of interpreting the English would have been, if it said during that time period, I would have assumed that it referred to the time period that was just mentioned because it was during that particular time period. But again, I mean, I could also have made another mistake somewhere deeper here because you saw I would have made some other mistakes in the problem. Okay, great. We got some time left. Let's keep going. And we deserve a little bit of a water break. Let's see. Ooh, geometry. This will be fun. Okay. Yeah, we have about 7 more minutes on this. 6 more minutes. Triangle ABC is isosceles with AB equals AC. Point D is on... Okay, let's start drawing the triangle. So I don't know what it's going to look like yet. This is a generic isosceles triangle which looks too equilateral. I don't like that. Equilateral triangles are too special. See this? This is now a long, skinny... This is now a long, skinny isosceles triangle. AB equals AC. It sure does. Point D is on AC such that BC equals BD. So point D is somewhere here, okay, such that BC equals BD. What does that look like? Maybe like this? Okay. All right. Okay. What else is here? So BC... Wait. No. BC equals BD, not BC equals CD. If I want BC equals BD, then it looks more like that. Actually, the way I'm making that one, by the way, is I'm sort of imagining some symmetry. I was like making an isosceles triangle. Okay, that looks better. So BC equals BD. And points E and F are on AB such that DE and CF are both perpendicular to AB. Oh, I'm drawing more perpendiculars. I can do that. So I have to draw this DE perpendicular. And CF is also perpendicular. Okay. Good. The ratio of the length of AB to the length of BC is 53. I'm guessing that maybe there's a typo and this is 5 to 3. Yeah, okay, good. 5 over 3. Yes, because 53 is kind of a big ratio for a problem. So this is probably, when we were transcribing the problems on our team, we made a slight mistake, but it should be 5 to 3. Okay, so let's go with AB to BC is like 5 to 3. Okay, so this is like 5, and this is like 3. By the way, I say like, but I could even say they are 5 and 3 because I didn't measure things in meters or feet or whatever. They are measured in our own units now, 5 and 3. Okay, what is the ratio of the length of DE to the length of CF? So I need to know those ratios. That's really neat. Okay, let's start looking at this problem. So notice that I said that these things are, this is an isosceles thing. So that thing over here is also 3. When in doubt, start labeling stuff. Okay, so that's a 3. I have a 5 and a 3, and that one went down. Okay. This is a really neat question. All right, I see how we can crack this. So this looks like a Pythagorean theorem-ish and similar triangles-ish thing. This is super cool. Okay. So I see some similar triangles, first of all. That's why I try to draw this thing carefully. You see this triangle down here? This is similar to the original one. You know why? It's because the original one's also isosceles, and they share that angle. So this little guy is similar to this big one. You know what that means? That means that the ratio of the long side to the short side is the same ratio. So the short side is 3/5 of the long side, right? So this short side is 3/5 of the long side. So now I know that this is 3/5 of the long side, which is 9/5. You know why I wanted to do that? It's because I'm looking at the ratio of the length of DE to CF. If I want that ratio, I've got more similar triangles. Here's one triangle, and here's the other one. So if I want to know the ratio of these lengths, I can say that's the same as the ratio of this length to the whole thing. What's the whole thing? 5. It's an isosceles triangle. That's why I was gunning for this piece, because I was like, I can get that now. Because the whole thing's 5, right? So that means this thing is 5 minus 9/5, which is 25 minus 9/5, which is equal to, oh, that's like a 3, 4, 5. So it's like 16/5. You see why I said it's a 3, 4, 5? It's because 25 minus 9 is 16. That's from a 3, 4, 5 right triangle. But this is not a 3, 4, 5 right triangle. It's just like that particular computation is in my head. But there we are. So that's going to be 16/5. That's going to be 9/5. And therefore, the ratio of the DE to the CF is exactly equal to the dA over CA, which is equal to dA was 16/5, and CA was just 5. And it's sort of going a little bit over my head, but this is 16/25. dE to CF. Yes. Okay. That's my proposed answer. Let's see if this is right. 16/25. It is, and we're good. Okay, as you can see, the geometry problem is actually easier for me than the crazy logic problem. But that's what makes these problems so interesting. With that, I think we actually ran in, and somebody said a comment, 2 square numbers. That's pretty neat. I have been very impressed by how nifty the problems are that come from Math League. As you can see, a lot of them I look at and I'm like, whoa, how is this possible? And then it turns out to be possible. That takes a lot of creativity to come up with questions like this. With that, we've run out of time for today, but we're going to be back tomorrow at the exact same time to continue on and play with some more of these problems from this Math League state route. See you guys there. Bye-bye.